es casualidad sentirme así. Esta sensación que siento te la debo a ti. Solo tú, mi amor, me has hecho olvidar todo lo bueno y lo malo que ayer viví. Tú y yo, culpables somos ya de querernos tanto y tanto. ¡Qué felicidad! Tú y yo, atados a un amor.
Pilot testing began in December in the Greg Hall High Bay and ran for the entire winter break. Piloting a scale version of our system was necessary to confirm that the flow from the office would be roughly 1 gallon per minute using our design. This was critical because if the flow was too low, then the water would have to be pumped to the office rather than fed by gravity. Since electricity is sporadic on site, we wanted to avoid using a pump for distribution as much as possible. A 250-gallon tank was raised 9 feet, the elevation of the roof on the school building, and PVC and flexible PE piping were connected to it. All the proposed elbows and T's in the design were added to the system to account for minor losses as well. For statistical variance, multiple runs were done with varying levels of water in the tank. This assured that, even when the tank was near empty, the flow rate would still remain at 1 gallon per minute. To confirm our pilot test results, additional computer modeling was done using EPA-NET. To determine the correct chlorine dose and the length of time the residual would be in effect, chlorine demand of typical well water was also used. Since the climate in the Dominican is much warmer than New Hampshire in the middle of winter, the samples were incubated. This was to make sure the chlorine residual would be sufficient after sitting in the sun for extended periods of time. We left for La Romana, Dominican Republic, March 8, 2013, and upon arrival, picked up our PE flexible piping from Cor Caribe. The following day, we visited Juan Pablo Duarte Elementary School in Cumayasa and a preliminary site assessment before beginning construction. This included checking that last year's system still worked, measuring dimensions of the site to see if our system could be built as designed, and finding the underground piping already on site. We also had to make sure that the piping to the bathrooms was functional, as well as take inventory on the conditions of the bathrooms. 3 sinks.
One's missing.
One's completely missing. The other one
Works. But it's not on, maybe?
Yep. And then this one works as well, as far as we know, right?
And this shoots out of here
And that's what
with
that.
a lot of pressure.
Yep.
And these all
These
work.
toilets both fill up.
I don't remember if they leak.
But I don't remember the leak. After a full site assessment, revisions to our initial design had to be made. One of these included changing the location of the tank from the school roof to the bathroom roof due to structural uncertainty. We also re-evaluated the use of benches to cover up exposed piping and instead opted for the local work group to jackhammer the concrete slab so the pipe could be installed below ground. This provided a more aesthetic and safer alternative for the school. Due to our limited time, the crew also dug the 120-foot trench needed to pipe to the office, so that our efforts could be used elsewhere. With most of the designs finalized, construction began the next day. Underground pipes were laid into place and the trench was backfilled. The broken slabs from the jackhammering had to be replaced with homemade concrete. Due to a miscommunication at the hardware store, mortar was purchased rather than cement. The mortar was mixed with aggregate found on site and poured into place. This was set overnight with the hopes that it would remain undisturbed when the children arrived for school the next day. The language barrier between our group and the community at times presented an additional challenge to the project. Due to the limited water available for drinking, hand washing, and use in the bathrooms, shut-off valves were installed on the toilets so that they would not be flushed excessively by the children. All the sinks were outfitted with new fixtures as well. While construction was happening outside, an education plan was taking place in the classrooms. The children were taught simple English words and a lesson plan revolves around good hygiene and correct hand washing techniques. An interactive portion using GlowGerm brought the students into the bathrooms so they could see the true results of using soap and water. Lesson plans were left behind for teachers to use in subsequent years. At the distribution points at the office and kitchen, sinks were constructed per request of the client. For convenience of filling water coolers, a spigot was added onto the sink in the kitchen. Wrench drains were designed and dug at each location to divert used water away from the buildings. Once the distribution pipes were laid, the chlorine dosing point to the bathroom tank was finalized. Although the water used in the bathroom is not intended for drinking, there is still a possibility of children drinking from the faucet. With this in mind, it was decided to chlorinate the bathroom water as well to treat the potential threat of viruses. When in operation, a dose of chlorine is pumped to the tank on the roof and mixes with incoming water as the tank fills. The filtering and chlorination system installed last year is still used to treat the potable water going to the kitchen and the office. Since the design was changed after evaluating the site, we were unsure if the flow rate at the office would be above the necessary 1 gallon per minute. A temporary faucet was attached to the piping in the office, and we ran some simple tests with only 6 inches of water in the tank.
Stop.
6.1.
Oh, that was a good counter.
So both pieces of data are pretty close.
Yeah, try it one more time for 3.
With the system successfully working, i.e. a minimum flow rate of 1.5 gallons per minute in the office and a chlorine residual of 2 milligrams per liter, we were sorry to go after 8 long days, but happy to know that we made a lasting contribution to this community.